Hi, Assalamualaikum. So today we will continue on revision past time paper code MAT455. We will still cover on topic chapter 1. Okay, remember I Miss Nora, so I will present to you the solution for this question. Okay, the first question for integral test is from July 2021. Okay, the question asks use the integral test to determine whether the series converge or diverge. Okay, so this one you need to use the integral test. If you use another test, so there's no marks given. Okay, the first step is you have to, normally I will let this function into fx equals to x power of 4 over x power of 5 plus 3. And then you have to turn into integral test. So you use this symbol of integral from 1 until infinity. And then you copy back the function. Okay. With respect to dx. And then to integrate, you have to put limit t approaching to infinity. We use t for this one. T approaching to infinity, 1 until t, x power of 4, x power of 5 plus 3 with respect to dx. So to solve this integration, we can let u equals to x power of 5 plus 3. You will get 5x power of 4 dx, and then du equals to 5x power of 4 dx. Because we want to substitute back into this one. Okay, don't forget to copy back the limit t approaching to infinity, 1 until t, x power of 4 over cube square root. Okay, and then u square, and then dx is du over 5x power of 4. And then this one we will cancel out. X power of 4, you can cancel out, and then 1 over 5 we will put in front. So 1 over 5 limit t approaching to infinity, and then you have to integrate 1 over, or you can write as u negative 1 over 2 1t with respect to the u. So when you integrate, you will get this 1 over 5 limit t approaching to infinity. You will get u 1 over 2 over 1 over 2, 1 until t. Okay, so next one, what you need to do, you have to substitute back 1 over 5 limit t approaching to infinity. Okay, you have to substitute, or you can change this one until you get this one. You will get 2 over u 1 over 2. Okay, then you have to substitute value for t and 1. So limit, so you get this one 2, t infinity 1 over yours, you take u x power of 5 plus 3 t1, 2 over 5 limit t approaching to infinity, 1 over t power of 5 plus 3 minus 1 over 1 power of 5 plus 3. And then you will get 2 over 5 limit t approaching to infinity. So this one you will get 1 over t power of 5 plus 3 minus this one 1 over 4. So as you substitute t equals to infinity, you will get infinity. Okay, 2 times this one, you will get infinity. So when you get the infinity, meaning that by using the integral test, this is diverged. Your series is diverged. Okay, so diverged. Okay, so next one, we will continue on question. This one is February 2022. Okay, use integral test. Okay, so this is the function. For the first one, you have to let fx equals to 1 over x ln x. No need to put dx yet because we don't want to differentiate yet. Okay, and then you continue with the first one, integral test, integrate. This one start from 2. Okay, you have to put 2. It's not normally 1. Okay, according to question, 2 until infinity. Then you copy back 1 over x ln x dx. And then don't forget to solve this integral test. You have to put limit t approaching to infinity, 2 until t, and then the function is 1 over x ln x dx. Okay, by using this one, by using this function, so you have to do is you have to let u, in order to integrate this function, is ln x. So differentiate du with respect to dx, you will get 1 over x dx. So for dx, you will get x du equals to dx. Then you have to copy back. Limit t approaching to infinity. Integrate from 2 until t, 1 over x u. And then dx is x du. So for this one, you can cancel out x. So limit t approaching to infinity. Integrate this one, 1 over u with respect to du. Okay, so you will get limit t approaching to infinity ln u. Is it? Yes, you will get ln u. Ln u 2 until t. Then you have to substitute what is the function for ln u. Limit t approaching to infinity. Ln u is ln x. From 2 until t. Then you substitute back limit t approaching to infinity. You have to expand this one, substitute t and 2 to solve the integral. So ln t minus ln 2. So you will get this one infinity. Okay, so by using integral test for this series, your series is diverge. Okay, diverge. By using the integral test, you can put the conclusion. Okay, conclusion is the integral is divergent, and so the series is also divergent by integral test. Or else you can put your conclusion series, you copy back your series. Okay, therefore, okay, series 1 over k ln k is diverge. This one also accepted. Alright, so next one we continue on third question. Okay, so each topic I do about 3 questions in order for you to understand better. So this one, and for the first one, I will focus on let fx. Okay, I just let this function into x term for x over 2 x squared plus 1. So the first step, don't forget, start from, this one is from 1 until infinity. Copy back your function for x over 2 x squared plus 1 dx. So the first step, sorry, you have to put limit. Okay, so don't forget to put limit. Right, limit t approaching to infinity from 1 until t, 4x over 2x squared plus 1 dx. So by seeing this function, you can solve by using let u. So you let u equals to 2x squared plus 1. So differentiate with respect to u, you will get 4x dx. So du over 4x equals to dx. Okay, limit t approaching to infinity, 1 until t, 4x over u. So your dx equals to du over 4x. Then you can cancel out this one. So limit t approaching to infinity, integrate with respect to u. So you will get limit t approaching to infinity ln u, 1 until t. Then you have to expand limit t approaching to infinity ln u is 2x squared plus 1. Okay, don't forget to copy back the function u, and then you can expand. So limit t approaching to infinity ln 2x is t squared plus 1 minus ln 2, so you get 1 plus 1. Okay, so you just conga, and then you will get limit t approaching to infinity ln 2t squared plus 1 minus ln 3. So the answer that you will get is infinity. Okay, so you can conclude that the series, therefore, series 4n over 2n squared plus 1 and start from 1 until infinity is diverged. Okay, so I hope you understand this method of integral test to solve this series. So the first thing first that you need to know is this one. You have to let into the integral test, since this one is integral test, and then you need to put limit in order to solve this series, and then you can use any other method that's suitable to solve the integration. Don't forget to substitute back the u function that you let, and then substitute back the value 1 until t or even 2 until t, and then don't forget to put the conclusion. Okay, the conclusion is very important because the question asks you either it's converged or diverged. Okay, now we continue for question absolute convergence. This one is from July 2021. Question number 3. Determine whether the series converge absolutely, converge conditionally, or diverge. So the first step that you need to do is you have to absolute the series given. So put the absolute notation. Series from k equals to 1 until infinity, -1 k plus 1 k over k squared plus 1. Okay, after you absolute, you will get series k equals to 1 until infinity k over k squared plus 1. Okay, then after you get this one, you have to decide what test that appropriate to check whether the series converge absolutely, conditionally, or diverge. So the test that we can use is we can apply the limit comparison test. Okay, so you have to write that you apply the limit comparison test. To apply the limit comparison test, you have to let ak equals to k over k squared plus 1 and bk equals to 1 over k. So which is you simplify this one for k over k squared, you will get 1 over k. So for bk, we can test using harmonic series. Okay, bk is harmonic series. And it's diverge. Next, we apply the limit comparison test. Limit k approaching to infinity. The formula is ak divided by bk. So limit k approaching to infinity, ak is k over k squared plus 1 divide, or we can times with k over 1. Then you will get limit k approaching to infinity, k squared over k squared plus 1. Okay, after that, you have to solve this one by dividing with the highest power. So limit k approaching to infinity, k squared divided by k squared over plus 1 over, and then you will get this one, 1, this one. If you simplify, limit k approaching to infinity, 1 over 1 plus 1 over k squared. So if you substitute the value k with infinity, your answer will get 1, which is it's more than 0. Therefore, it is diverged since the series of bk is diverged. Okay, since it's diverged by limit comparison test, what you need to do, you have to apply the EST test to test the converge conditionally. Okay, so you have to apply EST, alternating series test. Okay, to apply the alternating series test, what you need to do is you have to let ak equals to k over k squared plus 1, and we have two conditions. The first one, we check for the limit first. Limit k approaching to infinity, k over k squared plus 1. Then you solve this one by dividing with the highest denominator. Okay, the highest denominator is k squared. And then you will get this one, limit k approaching to infinity, 1 over k divide 1 plus 1 over k squared. And then your answer will get this one equals to 0, which is rule number 1 is satisfied. When rule number 1 is satisfied, you have to check for condition or rules number 2. Rules number 2 is an more than an plus 1. An more than an plus 1. So, variable for an equals to, also this one we use k, so ak. K over k squared plus 1 more than k plus 1. You have to add plus 1 to every k. Right, so k plus 1 squared plus 1, and then you have to simplify this one by cross multiplication. K plus 1 squared plus 1 more than k plus 1 times with k squared plus 1. Okay, after you simplify, you will get k cubed plus 2k squared plus 2k more than k cubed plus k squared plus k plus 1. So your answer is k squared plus k minus 1, which is more than 0. So by looking at this one, you can see that rule number 2 is satisfied. Since rule number 1 and number 2 is satisfied, by applying the AST test, we can see that it is convergent. Okay. Converge by AST test. So you have to conclude that the series is conditionally convergent. Okay, conditionally convergent. So what you need to do to check this series converge absolutely, converge conditionally, or diverge, the first step is you have to absolute the series, and then you have to find out what kind of test that appropriate to test, and then after the first test that you get is diverge, you have to do the AST test to show that it is conditionally convergent. Or if you do the AST test, you get diverge, so you can conclude that your series equals to diverge, is diverged. Okay, so now we can proceed. Okay, before we proceed, I show you this one. Okay, cannot go back, so it's okay. I will conclude later. Right, so now for July 2022, this is the series given. So the first step that you need to do is you have to absolute the series. K equals to 0 until infinity, negative 7 power of k. And then the function is k plus 3 over 4k. Okay, so after you absolute this function, you will get series k equals to 0 until infinity, negative, is it negative? No, there's no negative since we already absolute the function. Okay, so you will get 7k, k plus 3 over 4 power of k. Right, so by looking at this series, what kind of test that appropriate? We can solve by using, we can solve by using the ratio test. Okay, so by applying the ratio test, so you write apply ratio test. Okay, you have to write what kind of test that you want to use in every question. Okay, for ratio test, we need AK equals to 7 power of k, k plus 3 over 4k. And then for AK plus 1 equals to 7, k plus 1, k plus 1 plus 3 over 4k plus 1. And then you have to apply the ratio test, which is rho equals to limit k approaching to infinity, ak plus 1 over ak. So this is the formula. So you have to substitute limit k approaching to infinity, ak plus 1 is 7, k plus 1 in bracket k plus 4 over 4 power of k plus 1, and divide, we change to times 7k supposed to be. You have to write the 7k first. Sorry, 4k over 7k in bracket k plus 3. Don't forget to put the absolute. Okay, then you have to simplify this one. You can simplify this one 4k with this one 4k, we still have 1. And then 7k with 7k, we still have 7, 1. And then k plus 3. Okay, so we continue. Okay, limit k approaching to infinity, 7 power of 1, k plus 4, divide by over 4. 4 power of 1, k plus 3. Okay, so this one that you get after you simplify. So we can conclude that this one 7 over 4 is a constant, limit k approaching to infinity. This one you can solve by divide with the highest denominator. So you will get this one. Now you get 1, 1, this one is 0. So we can conclude that 7 over 4, 1. Okay, and then this is, we can say that it's more than 1 and it's diverged by ratio test. Okay, since it's diverged for ratio test, you have to apply the AST to check for the conditionally convergent. Okay, now we apply apply AST, alternating series test. So we have two conditions. So the function that we have is AK equals to 7k k plus 3 over 4k. So the first condition, we have to check for the limit first. K approaching to infinity, 7 power of k, k plus 3 over 4 power of k. So this one we can divide with the highest power. Limit k approaching to infinity, 7k divided by 4k, k plus 3 over 4 power of k divided with 4 power of k. So you will get this one, 1, and then after you substitute with the infinity, you will get infinity, which is not equals to 0, and we can say that rule 1 is not satisfied. Okay. Since rule 1 is not satisfied, we can conclude that you don't need to check for the rule 2. Okay, since 1 is not satisfied, we can conclude that since first condition fails, no need to show the second condition. Okay, you have to put some conclusion for the AST test that you are not to the second condition since the first test is failed. Right? The series diverge by AST. Okay, therefore, the series is conditionally convergent. Oh, sorry, it's not conditionally convergent since it get diverged. So therefore, the series is diverged. Okay, conditionally convergent, if you apply the AST test, you get converged. Since this one is diverged, therefore the series is diverged. Alright. Okay, now we proceed another example in order for you to get more understanding. Right, so now this question is from July 2020. Right, the first step that you need to do is you have to absolute this one. Absolute n equals to 1 until infinity. You have to copy back. So you need to write this one in order to get marks. Okay, don't skip. N plus 1 squared. So after you absolute, you will get series n equals to 1 infinity n squared over n plus 1 squared. Okay, by looking at this series, what we can say that we can use the divergent test, right? We can use the divergent test, right? apply divergence test. Okay, so limit n approaching to infinity n squared over n plus 1 squared. So limit n approaching to infinity, so you can expand this one. You will get n squared plus 2n plus 1, and we can solve by dividing with the highest denominator, n squared over okay. If we solve this one, we simplify, you will get this one 1 1. Okay, so continue. Limit and approaching to infinity, you get 1 over 1 plus 2 over n plus 1 over n squared. So if you substitute, what you get is equals to 1. Okay, for the divergence test, you will get 1, which is not equals to 0, and also we can say that it is diverged by divergence test. If it's diverged for divergence test, you have to apply the AST test. Okay, apply the AST test. Okay, we have two conditions. First one we do for the limit n approaching to infinity, n squared over n plus 1 squared. So if we apply this one, what you get is still the same as the divergence test. Okay, for the first condition, your answer will get 1 equals to 1, which is not equals to 0. Okay, same as we calculated earlier. For divergence test, so we can say that this one equals to 1. It means that rule 1 or condition 1 is not satisfied or fail. Rule 1 fail. The first condition fail. So if rule 1 fail, you don't need to do the second condition. So we can conclude that. So as usual, you have to write some remarks here. Since rule 2, rule 1, okay? Since rule 1 is fail, no need to show the second or rule 2 lah. If you do rule 1, okay, we change this one first condition. Since first condition is fails, no need to show the second condition. Thus, series diverge by AST test. Okay, therefore, the series, you can copy back the series, okay, you can copy back the series is diverge. Okay, this is the final answer for July 2020. Okay. So we can. Okay, now we proceed with the power series question. Okay, this is from February 2021. So the first step is you have to apply the ratio test for the absolute convergence. Okay, you have to write apply ratio test for absolute convergence. Okay, for ratio test, what you need to do, you have to find the AK and AK plus 1. So this one is AK equals to 1 over set K x minus 4 power of K, and AK plus 1 equals to 1 over K plus 1 x minus 4 K plus 1. Okay, so for the power series test, what you need to do is your objective if you have to find value of x. Okay, you have to find value of x. So you have to apply the ratio test first, and then rho equals to limit k approaching to infinity. The formula is ak plus 1 divided with ak. Okay, and then you proceed. Limit k approaching to infinity, ak plus 1 is this 1 over k plus 1 x minus 4. Okay, k plus 1, and then you have to divide. Then you will write this one set k over x minus 4 power of k, right? So this is the ratio test, and then you can simplify k approaching to infinity. You simplify, you will get this one x minus 4k, you still have 1 here. Then you will get x minus 4 set k over set k plus 1. And then x minus 4 you bring forward, x minus 4 limit k approaching to infinity. This one you can write as this one, k over k plus 1. Okay, then you can solve x minus 4 limit k approaching to infinity. We can solve by dividing with the highest power of denominator, k over k divide k over k plus 1 over k. Square root, don't forget to write this one. And then after you solve, you will get 1, right? So 1 over 1 plus 0, you will get square root 1. So this one, your answer is x minus 4, 1. Okay, or limit 1. You can write limit first as you get 1, right? Or just 1 only. Limit k approaching to infinity, 1 equals to x minus 4 times with 1. Okay, continue. Okay, continue. The interval for convergence is since rho equals to x minus 4 less than 1, your value would be x minus 4, negative 1, and 1. And you have to solve this one. So x equals to negative 4, bring this forward. You will get 3. And this one, negative 4, bring this forward. You will get 5. Okay, so this is your interval for convergence. After you get this one, you have to check for the endpoint. Okay, checking endpoint. when x equals to 3. Okay, so you have to substitute value x equals to 3 into the original series. So series k equals to 1 until infinity, 1 over set k x minus 4 power of k. So this is the original series. You have to substitute value of x equals to 3 in this series. So you will get 3 minus 4 power of k. So your series you will get 1 over square root k. 3 minus 4 is negative 1 power of k. Okay. By looking at this series, we can see that we have to use the AST test, right? So apply AST to this series. Okay, the first condition is limit k approaching to infinity, 1 over set k then you have to solve this one. So limit k approaching to infinity, 1 over k 1 over 2. You will get this one. You can divide with the highest power, or you can differentiate this one. I think you have to divide with the highest power. Or you just substitute. I think it's easy to substitute. So you will get 0 here. So when you get 0, first condition satisfied. Then you have to check for the second condition, which is AK more than AK plus 1. So AK is 1 over set K more than 1 over set K plus 1. And you can solve by cross multiply or minus okay, and then you can see that this one you will get more than 0. So rule 2 or condition, we say that condition, so we standardize condition. Second condition also satisfied. Satisfied. Okay, so we can conclude that this one is included. Okay, x equals to 3 is included. Next, we check for the endpoint x equals to 5. Okay, now we continue to check for endpoint x equals to 5. Checking endpoint x equals to 5. Okay, so you have to substitute value x equals to 5 into the original series. Five minus 4 power of k. So you will get series k approaching to 1, infinity 1 over set k, and then 1 power of k. So with this 1, we can see that 1 power of k is always 1. So series k equals to 1, infinity 1 over k 1 over 2. So for k 1 over 2, we can use this one p series where value p equals to 1 over 2, which is less than 0, less than 1. Okay, so when p series equals to less than 1, it is diverged. Okay, for x equals to 5 is diverged, meaning that x equals to 5 is not included. Therefore, the interval convergence is x, since 3 is included, 3 less than or equals to x less than equals to 5. Okay, this is the conclusion for our series, for this series. Okay, next we continue for the next question from February 2022. Okay, this is the interval convergence for the power series. First step, you have to apply the ratio test. Okay, apply ratio test for absolute convergence. Okay, so to apply the ratio test, k equals to k to x minus 1 k over 5 power of k, k plus 1 equals to k plus 1 to x minus 1 k plus 1 over 5k plus 1. So rho equals to limit k approaching to infinity, k plus 1 divide k, you will get limit k approaching to infinity. So you substitute value for k that you find earlier. Over 5k plus 1. Then you divide or times with 5k over k to x minus 1 power of k. Don't forget to put absolute, and then what you can do is you can simplify this one. So k plus 1, okay, 5k, with the 5k you still have 5 power of 1. 2x minus 1 with k, okay, you still have 1 here. Right, so as you simplify, you will get limit k approaching to infinity, k plus 1, and then you get 2x minus 1 over 5k. Alright, so to solve this one, you bring 2x minus 1 forward, 2x minus 1 over 5. Limit k approaching to infinity, so we left with k plus 1 over k. So to solve this one, you have to divide with the highest power denominator, 2x minus 1 over 5. Limit k approaching to infinity, you divide with the highest power, k divided with k plus 1 over k. Over k, that you will get this one, 2x minus 1 over 5, limit k approaching to infinity. This one you will get 1, 0, okay, you'll get 1 here. Okay, so 2x minus 1 over 5 times with 1. Okay, next you have to solve for the. Okay, continue as ratio test. We get it here, 2x minus 1 over 5. Okay, less than 1. So the series is to be converged. So what you need to do, you have to find the interval convergence. So for the interval convergence, -1 less than 2x over or minus 1 over 5 less than 1. So you have to solve this one. When you solve this one, you have to solve one by one. Okay, so this one you will get if 1 times 5 plus 1 divided by 2 less than x, 1 times 5 plus 1 divided by 2. So you will get this one, -5 plus 1. For 2, you will get -2 here. And then this one, you will get 3. Okay, this is your interval convergence. As you get this interval convergence, you have to check for the endpoint. Okay, so we're checking for endpoint. X equals to -2 first. Okay, we substitute x equals to -2 into the original series. So the original series is k 2x minus 1 power of k over 5k. So we substitute into this series. K 2 times -2 minus 1 power of k divide 5 power of k. You will get this one. -4, -4, -1, -5. -5 power of k times with k over 5 power of k. So series k equals to 0 until infinity, you will get -1 power of k. Okay, so this one, as we simplify, we get this one for x equals to 2. Now we have to see that what kind of test that appropriates. We can use the alternate series test. Okay, so apply AST. So we have two conditions, limit k approaching to infinity. K, you will get infinity, which is not equals to 0. So rule 1 is not satisfied. Condition 1 fail. As condition 1 fails, you no need to do the second condition. Okay, so you have to write some conclusion here for the AST test. Since condition 1 fails, no need to do for condition 2. Thus, series diverge by AST. Okay, so proceed. We have to check for endpoint. Okay, so this one is diverge, so meaning that is not included for -2. Checking for endpoint x equals to 3. So we sub into the original series. You will get this one k, this one 6 minus 5k over 5 power of k. As we simplify, you will get k only. Okay, so this one we can test for divergent test. And it also diverges by the divergence test. Apply divergence test. Okay, for apply divergence test, limit k approaching to infinity. So this one is k only. The function is k. So the answer you will get is infinity, which is not equals to 0. Therefore, it diverges by the divergence test. So the conclusion for the power series here, therefore, the interval convergence is x is between -2 until 3. So both is not included. Okay, this is the final answer for this question. Right? So we continue. Question July 2022. Right, the first step as we do is we have to apply ratio test. Okay, so you have to remember the step. Apply ratio test, which is AK equals to k squared 3x minus 4 power of k over 2 power of k plus 1, and AK plus 1 equals to k plus 1 square 3x minus 4k plus 1 over with 2k plus 2. Then you have to apply the ratio test. Limit k approaching to infinity. You have to divide k plus 1 squared 3x. You have to substitute into the formula, which is AK plus 1 divided by AK. Okay, actually this one is power. A bit confusing later. Times with 2 power of k plus 1 over k squared 3x minus 4 power of k. Don't forget to put absolute, and then you can simplify this one. 2k with 2 power of k, we still have 2 power of 2 and 2 power of 1. This one 3x minus 4 with k, we still have 1. Right. So as you simplify, you will get limit k approaching to infinity, k plus 1 square 3x minus 4 times with 2 over 2 power of 2 is 4 k squared. Okay, this is the answer as you simplify. So this one you can simplify, you will get 2. So you can bring forward the variable with x, 3x minus 4 over 2 as limit k approaching to infinity, k plus 1 squared over k squared. Okay, so you can solve this one. I put it here. 3x minus 4 over 2 limit k approaching to infinity. This one we can solve by dividing with the highest power of denominator. Right, so k over k squared. So this one also k squared plus 2k over k squared plus 1 over k squared over with k squared over k squared. Okay. So you will get 3x minus 4 over 2 limit k approaching to infinity. This one as you simplify, you will get 1. This one you will get 2 over k, 1 over k squared. This one is 1. So the answer would be 1 here. Answer would be 1. So 3x minus 4 over 2 is less than 1. So now we continue to solve for the interval convergence. And this one is converge. by ratio test. Don't forget to write converge, okay, by any kind of test that you use. Is it converge, either converge or diverge? Okay, now we solve for the interval convergence. So the function that we have is 3x minus 4 over 2 less than negative 1 and 1. So you have to solve this one. Negative 1 times 2 plus 4 over 3 less than x. You have to solve for left and right hand side. 1 power times 2 plus 4 divided by 3. So you will get this one. This one is negative 2 plus 4 divided by 3, you will get 2 over 3 here. And then this one you get 2, 6, you get 3 here. Oh, sorry, it's not 3, it's 2. Okay, so this one is your interval convergence. After you get this one, you have to check for endpoint. X equals to 2 over 3. Okay, checking for endpoint, sub into the original series until infinity. Your original series is k squared 3 times 2 over 3 minus 4 power of k over with 2k plus 1. So you will get k squared. This one simplify, you will get 2. You have x here. 2x minus 4 power of k over 2k plus 1. Next, we can simplify this one. Oh, sorry, there's no x. Since we have substituted the value for x here, so you will get this one as 2 minus 4, negative 2. Power of k. Next, we simplify k equals to 0 until infinity. You will get this one, we can simplify k squared 2 power of k over with 2 power of k 2 power of 1. As negative 1 power of k, we can write it here. Okay. So this one you can simplify. You will get series k equals to 0, infinity, negative 1 power of k, k squared over 2. So the test that is appropriate for this function is, for this series is AST test. Alright, so we apply AST test for the x equals to 2 over 3. Right? So the first condition is limit. We check for the limit first. K approaching to infinity. Your function is k squared. Right? So your answer will get limit k approaching to infinity. You will get infinity. You have to differentiate this one. Limit k approaching to infinity. You have to differentiate. You will get infinity here. which is not equals to 0. It's not satisfied for the condition number 1. As the first condition fails, no need to show the condition number 2. Thus, the series diverge by ASG test. Okay, now we continue to checking endpoint x equals to 2. Series k approaching to infinity, k equals to 0 until infinity. So k squared 3 times 2 minus 4 power of k divide with 2 power of k plus 1. You will get this one, series k equals to 0 until infinity, k squared 2 times this one 6 minus 4 2. 2 power of k over 2 power of k and then 2 power of 1. So this one you can cancel out. You will get series k equals to 0 infinity k squared over 2. Or you can rewrite as 1 over 2 series k equals to 0 until infinity k squared. So this one you can solve by using the divergence test. Apply divergence test. Okay, to apply the divergence test, limit k approaching to infinity. Functions of ak is k squared. You get infinity, which is not equals to 0. It is diverged. Therefore, we can conclude that the interval convergence is both is not included. Right? This is the final answer for this question. So I hope it will help you to answer your final examination. Right? Good luck. Then we continue on the next pastime.